Hey guys, so today we're going to be teaching you about the law of cosines, and that'll help you learn how to solve a triangle or find some missing things if you need it. This is by myself, JD Donnelly, Kayla Victor, Nick Hockey, Maddie Delude, Gio Jimenez, and Aiden Aguila. So we're going to be teaching a little bit about the history of cosines and the law of cosines, how they all got started. A refresher if you learned about cosines before, because I'm sure everybody's learned about cosines. Everyone knows SOHCAHTOA. We learned about this in geometry and algebra 2 before. If not, we'll fill you in. We're going to show you the formula because that's the most important part. Once you learn the formula, everything else is smooth sailing. We're going to teach you how to solve these, help you out a little bit, give you some examples to follow along the way. You have that notes packet, so make sure you pay attention. You can follow along. And ask for any help if you need it. Along the way, we'll be happy to help. Okay, so now after that introduction, we're now going to go to Jarrett, who's going to briefly explain the history of cosine, who discovered it, what year, and so make sure you get out your notes so you can answer some of these questions, fill out that notes packet. If you have any questions, let us know.
The laws of cosine and many other mathematic discoveries were found in Euclid's Elements, a book written by Greek mathematician Euclid and Ptolemaic of Egypt in 300 BC. That book was the key to logic, modern sciences, and problem solving. The law of cosines is applied in trigonometry and relates the cosine of an angle in a triangle to the lengths of the sides of the triangle.
So, like we said before, a lot of you have probably already learned about cosine, or you know what cosine is based off of what you learned in your geometry or algebra 2 class in recent years. But today we're going to be talking a little bit about something different. You learned about sine and tangent as well, but we're just going to be focusing on cosine. We don't want any of those. You probably remember that with cosine, it is the adjacent side over the hypotenuse sine. But we're not going to, it's similar to that, but it's not going to be in the same realm. So we're going to be focusing more on just the formula, plugging in the sides that you have and the angles that you have in order to find the missing side or the missing angle that you want. And this should help a lot. Alright, so what is the law of cosines? What is the main thing we're dealing with here? What is the main big deal? So law of cosines basically says if you have a triangle with lines A, B, and C, and you know two of the sides and the one angle in between, then you have enough information to figure out that missing side. And here is the three formulas you can use. So if you're missing any of the sides, you can use one of these three formulas. So say, for example, you want to find side A. So if side A is missing, you would do A squared equals B squared plus C squared minus 2 times B times C times cosine A. So now, if you haven't noticed, the lowercase letters mean the sides, and the uppercase letters represent the angles. And then if you wanted to find side B, you do B squared equals A squared plus C squared minus 2 times A times C times cosine B. And then to find the side C, you do C squared equals A squared plus B squared minus 2 times A times B times cosine C. And then this will help you find the side. We'll get into solving this in a few seconds. Okay, now that we taught you a little bit of what is the law of cosine, now we're going to zoom in more and focus on the formula a little bit more, that it may help you understand it if you're still a little bit confused. So we're going to take a look at this formula, and we're just going to use the solving for the C side as our example. So that would be C squared equals A squared plus B squared minus 2 times A times B times cosine of the theta angle. Now, if you don't know what the theta angle is, if you look up in the top right corner of the PowerPoint, theta represents an angle that opens up to the side that we want to solve for. So then if you take a look down at our diagram, it would be angle C, so that opens up to the side C, and it would be 39. So 39 is our theta angle. And a lot of you may be thinking that, oh, this formula looks a lot similar to the Pythagorean theorem, which is a squared plus b squared equals c squared. It is similar, but it's not going to get us the answer that we wanted. So we're going to just focus on the law of cosines theorem. Alright, so now we're going to be solving a law of cosines problem, finding the missing side. So now, this is the problem, this is the main thing. Get out your notes, because this is what we're going to be doing now. So as you look at our diagram, we have triangle ABC, and we're going to be trying to find the missing side, which is side C. If you look at the other sides, we have side A, which is equal to 7, and we have side B, which is equal to 12. And we have our theta angle, which is 39 degrees. This is all the information we need to solve this problem. You don't need to worry about angle A and angle B because we don't need them to solve this problem. So if you look down below the diagram, I've already done this, but I'm going to explain it, and it'll help you guys. You can write it out and follow me along. So since we're finding the side C, we're going to put that on the left side. So c squared equals a squared plus b squared minus 2 times a times b times cosine of the theta angle. That's the formula. So now we're just going to plug everything in. So we have c squared, which we don't know yet. That equals 12 squared. I just went right and put 144 because that's 12 squared. And then it would be plus 7 squared, which is 49. And then minus 2 times 7 times 12 times the cosine of 39. I'll give you a second to write that down. Alright, so now we are going to simplify everything up. So c squared, and then 144 plus 49 equals 193. And then we subtract that by 168, because that's negative 2 times 7 times 12. And then multiply that by cosine of 39. Now we have, once you simplify that and get them together, we have c squared equals 62.44. Now, depending upon what your teacher asks for, you can either round that down to 62 or you can keep it at 62.44. And then at this point, we're going to square root both sides, get rid of that squared on the c. So we're going to square root c squared, and then we're going to square root the other side, and that'll be 62.44 squared. And then our answer comes out to c is approximately 7.9. Okay, so now here is Gio, who's going to be doing another example problem for finding the missing side. You will follow along in your notes with the blank triangle. This will be the first one, and let us know if you have any questions.
So I'm going to be teaching you the law of cosines solving for a side. This is usually used for sides that are not perfect numbers. Like, it could be like, for example, in this one I'm going to do 33, 66, and 81. So it's not completely perfect. So this will be 33 degrees. We could call this angle A. This one can be 66. This will be angle B. And then this one can be angle C, and it's 81. So now you basically want to do this. If this is angle A right here, the opposite side, so this side right here, this would be side A. And the sides are always lowercase and the angles are always uppercase. So since this is angle C going across, you would have side C. Since this is angle B going across, you would have side B. So now let's say side C is 12, and then side B could be 8. So now what you want to do is you want to put in the equation. So it would be the side that you want to find, and you want to square that. So it's a squared, and then you want to have the sides that you do know, which is 8 and 12. You want to do b squared plus c squared minus 2 times b times c, and then times cosine, and then for the side you're finding here, which is a, you want to go back to angle A and use that angle for the missing cosine here. So that would be cosine 33. So now you just basically solve and you plug in. So it'd be a squared is equal to b squared, which is 8. So it's 8 squared plus 12 squared minus 2 times 8 times 12 cosine 33. Alright? Then you go back and you do a squared is equal to 64 plus 144 minus 2 times 8 times 12 cosine 33. And then be a squared is equal to, this would be 208, I believe. Go here. Yes. So 208 minus 2 times 8 times 12 cosine 33. So then you go a squared is equal to 208 minus 16 times 12 cosine 33. Then it's a squared is equal to 208 minus 12 times 16, which would be 12 times 4 is 48. 48 times 2 is 96, and 96 times 2 is 192. Cosine 33. And then it's a squared is equal to, it would be 208 minus 192, which is 16, is equal to 16 times cosine 33. So then you'd go back to your calculator and you solve for that. So 16 times cosine 33, and then you do the end parenthesis. And then at this point, you get that. So it would be a squared is equal to 13 point. And then if your teacher is asking for preciseness, you would go to the second decimal point. So it's 42.42. And now you gotta square it like you want a Pythagorean theorem. So it would be a equals, and then go here, square root 13.42. And then there's your answer for your missing side. So 3.66 is A. And that is how you solve. You do law of cosine solving for a side.
Okay, now all of you have learned how to do solving the law of cosine's problem, finding the missing side. And you followed along myself in Geo, and by this point you should have your notes filled out for that question. And now we're going to be moving on to solving a law of cosine's problem, finding the missing angle. If you're still stuck on the last question, let us know. We'll stop the video and then we'll focus on that, and then we'll move on to this. So now we're going to be going to this one. You can tell it's a little different already from the diagram. We have different stuff up, and this may be a little bit more tricky because we're adding different things. So if you need any help, let us know along the way. We'll stop the video, we'll talk about it, and let's get into it. So now, here you can tell that we have all three sides figured out, but we do not have any of the angles, which is a lot different from the finding the sides. So we're going to be trying to find one of the angles here, and you don't want to pick just any of the angles. You want to pick the angle that's going to be the biggest. So now you can find out which one that is by looking at these sides, and the biggest side is going to correlate with the biggest angle. So if you look here, we have side C is 15, which is the biggest. So that means that angle C will be the biggest. So now if you look at our formula down here, it is C squared equals A squared plus B squared minus 2 times A times B times cosine C. And now that we know all these sides, we're going to be plugging that in, and we will not be plugging in the theta angle like we did last time because we obviously don't have that. So once you plug it all in, we have 15 squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times cosine of C. And I'll let you guys get that down real quick. Alright, now that we simplify this, we have 225 equals 49 plus 100 minus 140 times cosine of C. And we got that just by squaring all the numbers and multiplying them. And now, if we go down below, so now we have 225 equals 149 minus 140 times cosine C. So we did here, we just added 49 and 100. And then our next step is we're going to be subtracting 149. We're going to get that out of there. So that'll give us 76 equals negative 140 times cosine C. So we just subtracted 149 from 225. So then our next step is we have 76 equals 140 times the cosine of C. At this point, we want to divide negative 140 out of there so we get cosine C by itself. So we're going to divide 76 by negative 140 and then negative 140 by itself. And there we get negative 0.5429. You're going to get some crazy answer. And it's going to equal cosine of C. But we're not done yet. That's not our angle. Now, this might get a little tricky. You might remember from last year. We're going to take the inverse cosine and multiply that by the answer we just got, which is negative 0.5429. And once you use the inverse cosine with that, we're going to get our answer, which is 122.8 degrees. Now, if your teacher wants to be precise, you can round that up to 123 degrees, but we're going to keep it at 122.8 degrees. And now here is Gio, who's going to be doing another example problem for you.
So I'm going to be teaching you law of cosines, how to find missing angles. So I'm going to draw a triangle. Again, they cannot be the same size. Same numbers. So let's make this. So since you're looking for angles, you don't know any of the angles in this triangle. So, but we'll still name them. So this will be angle A, angle B, and then angle C. And remember, the angles are always capitalized, and the sides are always lowercase. So then you go with your corresponding angle. So this will be side C, and we'll make that, let's make that 12 be side A, and let's make that 5, and you'll have side B here, and let's make that 8. So then you do the same equation you would do for finding missing angles. So then you would do whatever you typically, the most helpful thing here would be to find the biggest angle. And to be able to find the biggest angle, that correlates to whichever side is the longest. So since here, C, for side C, you have 12, which is the longest in comparison to 5 and 8, we're going to be finding angle C. So then C squared is equal to B squared plus A squared minus 2 times B times A, and then cosine. And then you want to do the angle that you want to find, so cosine C. Now you plug in the numbers that you have. So it's 12 squared plus, or equal to 8 squared plus 5 squared minus 2 times 8 times 5 cosine C. So now you basically just keep on solving. So 144 is equal to 64 plus 25 minus 2 times 8 times 5 cosine C. So now you solve it. So you add these two, and that would come out to 79. So 144 is equal to 79 minus 16 times 5 minus 80 cosine C. So now you subtract these two. Minus 79, you need to go into your calculator if needed. 144 minus 79 is equal to 65. So you go back, so 65 is equal to negative 80 cosine C. So now you want to divide negative 80 into negative 65, so that way the cosine is on its own, all over negative 80, and now you're going to get some crazy decimal, so 65 divided by negative 80, and that is 0.8125, so negative 0.8125 is equal to cosine C. So now is when it gets a little tricky. You want to take, for this part, you want to take cosine's inverse, so you want to do inverse cosine. So now basically, the angle you want to find flip-flops with this. So now you do that. So you do angle C is equal to inverse cosine, which is cosine negative 1, times negative 0.8125. So you put that in your calculator. Second, then you hit cosine again, and now it's negative 0.8125, fill in the missing parenthesis, and that would be your angle, or your answer for that angle. So angle C is equal to 144, and then if your teacher wants a precise answer, you typically round to the second decimal point, so that would be 0.34, and that would be your angle C here. And that's how you find missing angles for law of cosine.
And now you can go to your worksheet and work on some of the problems.